Okay, here is a video to help with elimination. So we're still solving systems of equations, but we went over solving by graphing and solving by substitution in the last video. This one's going to go over solving by elimination. And remember, with elimination, we are eliminating a variable. And the way we do that is we want to be able to add the two equations together and have one of the variables go away. In order for them to go away, if we're adding them together, we have to have the same coefficient in front of the same variable, but with opposite signs. For instance, in number 8, it's already set up for us. Look at the y's. The coefficient in front of the first y is a positive 2. In front of the second one is a negative 2. If I add these two equations together, 2x plus 8x, that's 10x. Positive 2y plus negative 2y, well, those are just going to cancel each other out. Equals 28 plus 22 is going to be 50. Now, notice how I only have one variable now. I can now solve for that variable and know what that equals. So I'm going to go ahead and do that. So we're going to divide both sides by 10. And so that gets rid of our 10, and we're left with 5. And then to figure out what y equals, we are just going to plug x back in. You may plug it into either one of the original equations. It does not matter, and you would get the right answer. So let's just use the first one. So 2, I'm going to plug in 5 for x, plus, I'm just using that equation right there, 2y, y is what I don't know, equals 28. 2 times 5 is 10, plus 2y equals 28. And now I'm just solving for y. I need to move some things away. So let's move the constant first. So we'll subtract 10 from both sides. We're left with 2y equals 28 minus 10 is going to be 18. And then divide both sides by 2 so that y is by itself, and we get 9. So the x value was 5. And the y value was 9. So with elimination, we are trying to get coefficients in front of the same variable to be the same number but opposite signs. If they're already there, great. Go ahead and just add the two equations together. They'll go away for you. Solve for one variable and then plug it back into one of the original equations and solve for the other. But what happens if, like on number 10 here, we don't have one? Hold on a second, let me move this. Okay, so if you look at the coefficients here, in front of x, we have a 4 and a 7. In front of y, we have a 5 and a negative 3. We don't have the same numbers. Now, in front of the y, we have opposite signs, so that's a start, but they're not the same number. So here's what's going to happen. If you have a situation where we do not have the same coefficients in front of variables, I need to make them the same. And the way we can do that is we can multiply by whatever number we need to. Now, as long as you multiply the entire equation by the same number, it's okay. So let's say, since these are already the opposite sign, let's say we're going to get rid of y. Well, what's the first number that both 5 and 3 go into? Well, that's going to be 15. What would I need to multiply 5 by to make it 15? I would need to multiply it by 3. So I'm going to multiply the whole entire equation by 3 because I can't just multiply 5 by 3, but if I multiply everything by 3, it keeps it all the same and it's okay. So 4x times 3, that's 12x. 5y times 3, that's 15y. And 22 times 3, that's 66. Okay, so 5 needed to be multiplied by 3 to make 15. Now, 3 is going to need to be multiplied by 5. And I already have the opposite sign there, so I don't need to multiply by any signs, because remember, I want them to be the same number, but one needs to be positive and one needs to be negative. So let's multiply everything here by 5. So 5 times 7x is 35x. 5 times negative 3 is negative 15y. And 5 times negative 32, I mean, either need to go over to the side or get a calculator for that one, is negative 160. Okay, I know I've multiplied by the right number if I have coefficients that are the same number, but one's positive and one's negative, and I do. So now I can add these two equations together 12 plus 35, that's going to be 47, and they're both x. 15y and negative 15y, well, those are going to cancel out, which is what I wanted them to do. 66 and negative 160, that's going to be negative 94. And now I can just solve for x. I got rid of one of the variables. So if I divide both sides by 47, x equals negative 94 divided by 47, which happens to be negative 2. Now, to figure out what y equals, I can plug negative 2 back in for x in either of the original equations. Let's just use the top one. So 4x plus 5y equals 22. I'm going to use that, plugging negative 2 in for x. So 4 times negative 2 in place of x plus 5y equals 22. 4 times negative 2, that's negative 8. And now I'm going to solve for y. So I need to move the constant first. That's a negative 8. So I'm going to add 8 to both sides. So I'm left with 5y on the left and 30 on the right. And now I just need to divide both sides by 5. Sorry, getting off the page here. And y equals 6. So my solution here is negative 2, 6. I hope this helps you understand elimination a little better. If you have further questions, please don't hesitate to ask.